Now, for these next few ones, it says go from scientific notation to standard form. So this time we're going backwards. Well, this is a positive, so it's going to get bigger. We have to move 2 spaces. So 1, 2, that is just 254. On a negative value, 6.7, we've got to move 2 spaces, and it's negative, so we're getting smaller. So 1, 2, any empty spot put as 0. This is 0.067. I want you to try these 4. Push pause on the video until you've tried it. Push play when you're ready to see the answers, okay? Push pause now. Alright, so 9.1 times 10 to the 5th, so it's going to go over 1, 2, 3, 4, 5 times. Well, all these blank spots put in 0. So 1, 3, it needs 4 zeros. So 9, 1, and 1, 2, 3, 4 zeros. 5.88 times 10 to the negative 4, so move back 1, 2, 3, 4 spaces, and it needs 1, 2, 3 zeros in front. So 1, 2, 3 zeros, then 5, 8, 8. 1.14 times 10 to the 3rd, it's getting bigger, it's positive. 1, 2, 3, empty space, fill it with a 0, so it's 1, 1, 4, 0. 3.8, 10 to the negative 1, move it 1 space smaller, so just 0.38. Alright, now, if we have adding or subtracting, what we can do is, first we've got to make sure the exponents are same. Then, what you're going to do is use LARS, which stands for left goes add, right goes subtract. You're going to shift the decimal and change the exponent. Then you can add or subtract just the numbers and keep that common exponent. So here's what I mean by that. Let's look at this first one. 3.4 times 10 to the 2 plus 5.2 times 10 to the 2. This time they have the same exponent, the same value, so we're just going to add them like they're like terms. 3.4 and 5.2, when I add those together, I get, that's a 6, and this 8. So it's 8.6 times 10 squared. Keep the same exponent on that. Now, if you look at number 2, these ones have different exponents. This one's a 7, this one's a 6. So I can either change this one into a 6 or this one into a 7. I'm going to use the right subtract. So I'm going to move this 1 to the right, and I'm going to subtract the exponents from 7. It goes to 6. So I've got 95 plus 1.1 times 10 to the 6th. Well, when I add up 95 and 1.1, I get 96.1 times 10 to the 6th. Now, there's one problem with this. The problem with this is my decimal number is now a lot bigger than 10, so I need to move this one backwards. When we move one backwards, this is going to go up to 7 again. So 9.61 times 10 to the 7. You want a decimal number that is still in between 1 and 10. Number 3, I've got 10 to the negative 4 here, 10 to the negative 5 here, so one of those has to change. Well, if I move this one over one more to the left, I'm going to add the exponents. Now, 1 adding to a negative 4 would not make it a negative 5, that would make it a negative 3. So let's move this one to the left, and let's add here. So instead of negative 5, we'll get negative 4. Now the exponents are the same, I can just add the numbers. So 0.318 adding to 7.24, so this is going to be 7.558. Exponent letters are the same, so 10 to the negative 4. So, one more. 6.8 times 10 to the negative 3 and 2.7 times 10 to the negative 2. Well, if I move this one to the left one, I'm going to add to the exponent. So if I move this to the left, I'll add from a -3 to a -2. Now I can combine my exponents. This is 8, 13, carry 1, 1 plus 2 is 3. 3.38 times 10 to the -2. So if you always make one of your numbers to where it is smaller than 1, when you combine them, you should get an answer. You don't have to change back like what we did on the second one there. Alright? I'm going to stop the video here. We'll continue on the next one.